Hello everyone and welcome to the fourth question on the 2022 final exam in analysis in one variable. So, as you see on the screen, the fourth question is formulate the mean value theorem. The mean value theorem states that if f of x, which is some real to real function, is differentiable on the open interval a to b and continuous on the closed interval a to b, then there exists a c within the open interval a to b such that f prime of c is equal to f of b minus f of a over b minus a for any pair a and b which are not the same, obviously. Yes, that is the mean value theorem. Moving on to the second part. Show that if f prime of x is equal to 0 for all x on an interval, then the function f is constant on the interval. So essentially what this means is that if f prime of x is always 0, then no matter what you choose a and b to be, f of b minus f of a over b minus a will always be 0. Which means, because b and a are not the same, which just means that f of b is equal to f of a for any pair f of b which are not the same, which just means that if you can pick any pair and they're always the same, that means the function is constant everywhere. So yes, so that was kind of easy. And now we're moving on to the third part, which is a bit more tricky. But then I need to erase something. So give me 1 second. I'm back. So the intuitive explanation to the mean value theorem, which I thought I'd give before we move on, is basically that, okay, so we have any graph that is, well, it looks smooth. That's essentially what we're saying with it's differentiable and continuous. So imagine if you have a graph that looks something like this, maybe. We have your x coordinates a and b. Then the mean value theorem says that there has to exist some point within this interval such that the derivative at this point is equal to the slope of this line right here that goes straight through the points. And that really makes sense, because if it's just a straight line, then it goes through everything, and if it goes below, then it has to like scoop upwards again at some later point. And that's exactly what we're seeing here. So you can see here from this point we have the exact same slope, so therefore our c would lie specifically there. So yes, that was just a quick side tangent if you hadn't talked about the mean value theorem before. So C, show that arcsine plus arccos is equal to pi over 2 for all x within the interval -1 to 1. So then we denote a so-called help function. So we denote f of x to just be equal to arc sine of x plus arc cos of x. And then we denote the derivative of this. So we want to prove that this is constant. And what did we just say about constant functions? They have a zero derivative everywhere. So the derivative of arcsine is, maybe I'm flipping these, I'm not entirely sure. No, I don't think so. 1 over 1 minus the square root of 1, and the derivative of arccos is just minus the same thing. So 1 minus 2, which is obviously just 0. So therefore we know that our function f of x is constant everywhere, and therefore we know that f of x is equal to some constant everywhere. And what is this constant? Well, we obviously just plug in something. So we try 0, because that one is really easy. So then the arcsine of 0 is just 0, and arc cosine of 0 is pi over 2, meaning that this is just pi over 2. So therefore it is equal to pi over 2 everywhere, because it is a constant function. So yes, that was the entire question 4. Hope you enjoyed the video. Please check out the link in the description. And moving on to problem number 3.